So let's do a little overview of what I'm going to talk about first. So first, I'd like to talk about the motivations around Service Catalog, what niche it's filling in the Kubernetes ecosystem, and why it's important. And then I'll introduce the Open Service Broker API, which is the API that Service Catalog is backed by. And then finally, we'll take a look at the new resources Service Catalog gives you and what a typical flow would look like when interacting with it. And then hope to do a demo if everything goes smoothly. And finally, a Q&A. So what is Service Catalog? In one sentence, Service Catalog is a Kubernetes extension for the discovery and connection to externally managed services. So the idea is we want to bring the concept of external managed services into the Kubernetes ecosystem as a first-class citizen. And let me talk a little bit about what those managed services actually are. So I'm going to do a goofy little example. So let's say you're a web app developer who's trying to come up with the biggest new startup. And you know that people really like taking and sharing pictures of their cats. And you suspect there's a real problem today, though, where people really want to know whether the pictures they're taking will be highly upvoted on Reddit or liked on Facebook before they share them. So you want to develop an app that people can upload their pictures to, and it will predict how well that picture will do on social media. So what are the sort of components you would want for this app then? So obviously, you would want the web interface. That's what your bread and butter. But then you also need some sort of bucket storage for the cat pictures. You need an ML engine to do the actual prediction aspect. And you probably want some database to maybe store previous cute cat prediction results. But as I said, your core competency is the web app development. You really don't want to be in the business of having to manage your own like TensorFlow deployment or a SQL server in your cluster. And you happen to know that, hey, Google has a really good ML engine that you could use. But maybe you want to use IBM Cloud's databases, and maybe you found some free bucket store somewhere that's good enough for now, and you can swap in and out later with something more robust. So that's sort of the concept of externally managed services. In this case, you would have your web app running in pods on your K8s cluster on-prem, but it reaches out to multiple services outside the boundaries of your cluster. And that way you can focus really on only having to manage your deployments, your services, your resources, but you can trust the hosted services to be managed by their providers. And so that's the dream of sort of the hybrid cloud services story in Kubernetes. But this model could also apply to services just within your single company as well as it grows larger. So different teams in your company might be responsible for like the billing service or a logging service or their own managed database. Outside the realm of Kubernetes, and you still want to be able to interface with those easily from within your cluster. And so that's great in theory, but what does that look like today in Kubernetes? So first, you need to get access to these services, and that's going to have to be completely out of band with Kubernetes. So you'll have to go through the web UIs of whatever service providers you're interested in, probably authenticate 100 different times with OAuth, or maybe there's a proprietary CLI tool you need to download in order to manage your interfacing with these services. Or if it's internal in your organization, maybe you need to like file a ticket for a different team and wait 3 days before somebody brings you a Post-it note with like username and password for your database instance. And then you have to manually inject that into your cluster somehow, so you probably create secrets. But that's just deploying it one time. So maybe each developer really needs their own isolated environment to develop in. So you'd want a cluster per developer, or maybe a namespace per developer. And then there's the test cluster, the staging cluster, the production cluster. And you want each of the instances of these external services to be sandbox, really. You want them to have, the applications to have their own views of these services. And so you probably need to start writing a bunch of scripts in order to handle the interfacing with whatever APIs are offered by the service providers. So that means every time that you deploy your app, you also need to run these scripts. And these are your scripts, so good luck maintaining them. And then you have to interface with the K8s API in order to automatically inject the credentials. And then the lifecycle of these things aren't tied to your application, so you also have to write scripts to tear down the services. And hopefully everybody remembers to run those, or you're going to be leaking resources all the time. And I think that's not the best story, because I believe that we're heading towards a world of many different interconnected services from all different service providers, not just the big ones. And I think with products like Istio, that story is really taking off for inside of your cluster, inside of Kubernetes, but what about outside that bound? What about outside the bounds of whatever maybe hosted Kubernetes environment, or like hosted cloud provider you're running on? And the more friction I think there is with connecting services and connecting clouds, the less that people will create services for people to consume. And so you'll have your bucket of maybe Google Cloud services, your bucket of AWS services, the big players, but you won't see a truly hybrid story. And so that's sort of the state of the world today. And so I'm wondering we were wondering, how do we make that experience better? And if we're designing the concept of externally managed services in Kubernetes from the ground floor, what would we want? So firstly, just like all other resources, it should be declarative. So I should tell Kubernetes what external services I want, and Kubernetes, just like all the other resources it manages internally, should do the heavy lifting to make sure that happens. And the lifecycle should be tied to my application's lifecycle. So I should be able to kube control apply my entire manifest directory, external services included, and everything just spins up as expected, and then kube control delete, it all tears down as expected. And secondly, I think it should ideally be a consistent API. So you could make CRDs and controllers for all the different possible external service types. But I think in the interest of like portability, moving from one hosted SQL to another, and also as far as like the extra resource cost, the extra infrastructure cost, and the extra baggage for people to have to understand all the different resources. And not to mention that if you want to be able to build a good GUI dashboard on top of all these arbitrary implementations, that would be hard. And so ideally, as well though, we wouldn't create our own standardized API to expose these services in Kubernetes. We should leverage something bigger than just Kubernetes. And ideally, we wouldn't also need to create custom logic to front all existing service provider APIs. And so luckily for us, there's an industry standard emerging for discovering and connecting to managed services. And that's the Open Service Broker API. So this is an API that CloudFoundry originally kickstarted for interfacing with external services in their marketplace. And since then, it's started to be adopted as an industry standard with collaboration for the last couple years from Pivotal, Google, IBM, Red Hat, SAP, and more. And so how the model works is that service providers create service brokers. And those service brokers expose a catalog of service offerings. And so developers can just browse the catalog, and if they see a service that they want to use, they tell the broker to provision a service instance, which represents their own sandbox instantiation of that service for them to use. And then any developers that want to use that specific or connect that specific instance to their application can bind their application to that instance. And this creates a unique set of credentials for that application's identity and that relationship. And so that's like a bird's eye view of the API. And there's a little bit more customization involved. So there's the concept of plans of a service, which are basically just different flavors or tiers. So you could have like a free tier, you could have a paid tier, a premium, or a HA1, just depending on what the service broker implementer wants to offer. And then each plan has schemas for parameters when creating instances and when binding your application. So it's a simple API, but I think it really has, like the power of it is in its simplicity. And so with that foundation, let's take a look at Service Catalog. So at a high level, Service Catalog is a Kubernetes extension that exposes a declarative and consistent API for interfacing with externally managed services using the Open Service Broker API. And so to do that, we've taken all the concepts of the OSB API and mapped them into what feels right for Kubernetes resources. So these are the resources that we came up with then. So it looks exactly like the slides a couple ago. So there's service broker, service class, service plan, service instance, and service binding. So service class is how we describe the service offerings. And that's a little bit of a lie, though, because what we actually ended up deciding for our V1 Beta 1 was we wanted broker classes and plans to be cluster scoped. So it's the responsibility of the cluster admin to be the one adding the brokers that all the developers in that cluster could use. And currently we're working on namespace versions, though, so that's coming in the next couple months. And then instances and bindings are namespace scope for the time being. And so let me just go over sort of the resources that you would be directly creating. So cluster service broker, that represents the external broker that you're communicating with. And as part of its spec, you define the URL that it lives at, and you specify a secret containing credentials to talk to that broker. And so this is the only part that has to be negotiated out of band of Kubernetes. Once you get that injected into your environment, then everything else is just creating declarative resources. And so once you create the cluster service broker resource, our service catalog controller will connect to the broker and learn the catalog of service offerings from that broker, and it will create cluster service class and cluster service plan resources to represent those in your cluster. Then you can browse the catalog of services, and when you find something that you want, you can create a service instance resource. So you specify the class, the plan, and then any parameters that were specified by the schema of that plan. And so just one thing is that we use the external name of the class and plan just because there's a difference between the OSB concept of its external name and then the Kubernetes concept of its internal name. So you can specify either, but this example just uses the external name. And then once the service instance is provisioned, you can create a service binding resource, which represents your intention to bind, or in other words, like the relationship between your application and your instance. And as part of this, you specify the instance you want to bind to, so the instance ref, and then any bind parameters. And as a result of the binding, our controller will create a secret in your application's namespace with any information needed for your application to talk to that instance. So like credentials, hostname, port. And the secret name will, by default, just be the name of the binding, but you can specify that. And of course, because it's Kubernetes, it doesn't matter the ordering of which you create any of these resources. So you can create the binding, then the instance, then wait a while, create the broker, and then everything will become eventually consistent. And same for deleting the resources. And so that's the experience with using the service catalog just manifest of the resources directly. But it would be also nice to have a little bit more command line porcelain around the experience, to be able to do things like easily browse the catalog for maybe services from specific brokers or plans of specific classes, or do imperative commands like I want to refetch the catalog or provision or bind. And so for that, we created a CLI tool called sveat for these service catalog specific actions. And so it also has a mode that it can operate as a kubectl plugin. So you can do kubectl plugin sveat. But because the plugin ecosystem is not quite mature yet, I would personally recommend the standalone. And let's take a look at a little demo. So this is a, oh, let me actually. Second. Let me try to get my terminal mirrored. Let me see how to mirror my window. There we go. All right. So this is just going to be a little bookstore web app demo. So the idea is that you have a bookstore with a bunch of books that you can purchase, and every time you purchase a book, it sends a message on PubSub. And so the PubSub will be the externally managed service. So So here are all the resources for the internal, all the internal resources. So the deployment of the bookstore, the services it relies on. So I'll just kube control apply this directory. There we go. And so the idea is that in the Books FE, the Books FE pod won't come up quite yet because I have the deployment relying on the PubSub secret that we expect. So we can see that I am mounting a volume for the credentials for PubSub, and then I'm specifying an environment variable for that information, and then I specify the PubSub topic. And all this comes from the PubSub bindings secret. So now let's actually create the PubSub. So I'm going to show the two different flavors, the imperative CLI and then also the manifest files. So first, let me do sveat get broker. And so you can see that I have the Google Cloud Platform Service Broker currently registered in my cluster. So that means that since it's ready, we should be able to do get classes. And now we can see all the Google Cloud Platform services that are exposed to us. So in this case, we're interested in the Cloud PubSub one. So let's just look at that one a little further, see what plans it has. Oops. Actually. So we can see that it has a beta plan. So that's the one that we're going to use. So let's use sveat to provision that. Oh, first actually, let's look at any parameters that it needs. So we can do that with sveat describe the plan. And so here we can see that there's some there's an instance create parameter schema. And what we can see inside of here is there's just one property that it needs, which is the topic ID, so the PubSub topic. So I can go ahead and do sveat provision, let's call it PubSub, class Cloud PubSub, plan beta, and then give it a parameter topic ID equals kubecon. And so now this should be provisioning for us. So we can do get instance. Yeah, we can see that it's provisioning. And if we want to look at the Kubernetes resource, we can do get service instance. PubSub. And so now we can see here's the spec that was created for us automatically by sveat. And then also here's some conditions. So in this case, we have it's provisioned successfully. So now we can just look at the instance real quick. And so sveat says it's ready. So now let us bind to this instance. So in this case, I'm going to do the YAML file. So let me first apply that. And then let's take a look at that file. And so it is a service-binding resource, API version, service catalog, K8s.io. And its name is pubsub. It references the pubsub instance, and it just has a few parameters, roles that we want our own service account for this, and then also create us a subscription. And now, this one takes a little longer to get up and running, so let's just wait for the service binding resource. Oops. Or if there's a quick question or something, I can take that. Oh, there we go. Okay, so it has injected the bind result into our cluster. So now we can do kubectl get secrets. And we see that there is a pubsub secret created 12 seconds ago. And so if we look at that real quick, we can see that we have the private key data for interfacing with the service, and then we get some useful information that we might just want to use in our application. So project ID, service account name, and then subscription ID and topic ID. So now that that secret's up, we should actually have our pod up and running. And maybe let's just wait on it. Timeout expired. Okay. Yeah. Oh, okay. Cool. Okay, so now that the pod's up and running, let's get the Kubernetes service IP for this. And so here's our bookstore application. So we have a couple of interesting books. A Game of Tones. Tone-deaf 10-year-olds are pitted in an a cappella battle royale where only one will survive. I would like that. So let's go ahead and purchase that one. Okay, and then if everything worked, we should be able to see that there was a purchase message for that one. So in this case, I made a script that just does the gcloud pubsub subscriptions pull. And now if we get the message, we see that there was one book purchased. And if we do it again, oh, it's reading probably from the previous one I had. So let's, my previous demo. Oh, sorry, I've run this demo with the same exact subscription name multiple times, so. But that's the idea, is that this allows you to just really easily interface your pubsub application, pubsub service with your application. And so now we can see that we can just easily deprovision these resources as well. So in this case, I'll unbind. And deprovision. What did you say? Oh, you bought the books. Okay. Okay, that'll makes a lot more sense. I was like, huh? I thought it. I didn't want it to make it seem like it was smoke and mirrors, but that was... OK, cool. Yeah, so that makes sense, because it's 2, 3, and 4. So the shelf is index 1. So this is book 2, 3, and 4. And I bought 3 first, so that's why it's 3. OK, so now our binding's gone, which also means that our resources should have been cleaned up. So if we go back to my get messages script, we should see that now it fails because the service catalog resource was deleted. So the external service was also cleaned up for you. And 1 second. Just going back to the slides. OK, so that's pretty much the end of the talk. So here are some of the resources that you can get involved with if you want to learn more. So we have a SIG for Service Catalog. Its meetings are Mondays at 1 Pacific time weekly. And then also for the Open Service Broker API, it's Tuesdays at 9:30 Pacific time weekly. And with that, are there any questions? Yes. Well, it's a V1 Beta 1 API, which means we're not going to pull the rug out from the API itself. And I believe, I would say it is production ready. I believe OpenShift is running it in production perfectly fine. Yes, books is not. I think I saw him first. Oh, OK. How about you?
How to deploy, to create a binding or a service request from a NEM chart? How is it possible?
I'm not familiar with NEM charts. Morgan.
Okay.
Helm. Oh, Helm.
Yeah.
Yes. Yeah, you can. That's originally how I had been deploying a lot of my services. But yeah, it doesn't have to be Helm. You don't have to worry about managing sort of ordering or anything. You can just add the manifest to your.
And then I have another question. How does it make sense to use this for an already provisioned database in production? Would it make sense to use a service catalog? Or?
I would say so, yeah. So right at the moment, that's more of a question for the implementation details of the service broker. So what I see service brokers doing now is offering plans that represent currently provisioned resources. So the things that were made outside of the scope of the Open Service Broker API, you can still pull them in to Service Catalog. And then the bind and everything works just as expected.
Do you see a use case for adding things like storage, SDS solutions or drivers to your cluster? Because, for using Open Service Catalog and OSB?
Yeah, I absolutely think so. We're having some talks with some of the Kubernetes story, like the CSI people, and how we can get more involved there. There's some questions as far as lifecycle, as far as migration of data, how maybe OSB can help you with that. So we have a concept of API extensions coming, where we are able to define, or brokers are able to define an API on top of the instances that is able to be managed by the platforms. So that's how we could have some aspect of migration and such.
Okay.
Correct me if I'm wrong, but you have taken ownership of the pod presets?
So currently, Morgan, yes, we did take ownership of pod presets. This is not currently in our demo. We are in our current build because we originally had pod preset bindings. which were able to just automatically create pod presets for you, we decided to work on revamping that a little. So for now, the story is just create the secret and then you consume the secret. But what our hope is that, yes, you will be able to create a pod preset automatically with your binding, and then your applications will just have the necessary environment variables and volumes just mounted automatically.
And this mean, and it means that the pod preset in the main Kubernetes repository will be gone probably at some point because it's still v1 alpha.
Yes.
Okay.
Yeah.
I saw an additional project called Service Manager sitting on top on the Service Catalog.
Yes.
And Google, IBM, and SAP is working on that. What's the role of them?
So Service Manager is about the concept of, okay, Service Catalog is really good at managing the external services that you created inside your cluster. And also you can pull in stuff via the broker if they provide specific plans for pulling in already provisioned resources. But what's the story around sharing instances between different instances of Service Catalog or between CloudFoundry and Service Catalog? So Service Manager is a layer on top that allows you to register your brokers with Service Manager, and then Service Manager is able to expose a broker API to the controllers that register with it. And then you're able to see already provisioned instances as plans, and the broker doesn't even need to support that functionality. It's a separate project, yeah.
Is there a technical reason why you use Kube aggregator and a separate API server and the controller, or is that just
It is because we were a very early adopter of sort of the extension, Kubernetes extension concept. And so, yeah, CRDs didn't exist when we started with this. Yeah, TPRs existed, but we wanted a bit more of a, yeah. We are looking currently into where CRDs and webhooks and such play into Service Catalog, if it makes sense maybe to even move it to CRDs and webhooks. But currently, yeah, we use API aggregation.
The other question, I just wonder in the productive environment, I mean, connecting services, you're assuming you will have the connectivity, right?
Yes.
I mean, in real enterprise, you have these bloody firewalls over the place, and
yes,
I mean,
yeah,
you need to do more stuff around it, right?
Yeah. Yeah, currently the Open Service Broker API assumes that you have the connectivity. And that's something that we're actively talking about in OSB. How do we give the plug points to be able to expose different networking sort of configuration? And I believe Service Manager, though, also has this in mind. It's something built into that. So if your platform can talk to Service Manager, then you should be able to talk to the brokers, assuming that the brokers can talk to Service Manager. They will or won't? Yeah. Yeah.
So in one of your diagrams, you showed other Kubernetes clusters, so kind of referencing services within another Kubernetes cluster. Is that something that's supported, or did I just misinterpret that slide?
Well, that was more that you would front your applications as OSB services. So you would create a service broker, your team would create a service broker exposing your application. And then other teams could, because if you exposed it as a Kubernetes service, as long as there's the network connectivity, it all plugs in and plays well.
Last question.
From the documentation, I got an impression that this whole paradigm is pretty much provider-oriented, service provider-oriented. What about to use this pattern for integration of external services, external relative to Kubernetes cluster, but inside of enterprise? For example, database, Kafka, message broker, whatever. And what I miss here, where to find already existing broker implementation, service broker implementations for such such tools. I can't imagine that everybody should implement provisioning of Postgres database user themselves. Should be some kind of catalog, easier to find.
There are some so if I understand your question correctly, are you asking what is the tools provided in order to be able to easily create brokers? So we have an OSB starter kit from Paul Morey at Red Hat is one of the implementations. I think Scott Nichols from Google, he has a different OSB starter kit. Okay. Okay. Nice. And that's also something that we just talked about a couple weeks ago at the Open Service Broker API face-to-face is we really need to provide tools to make it really easy to provide brokers. Yes. And I think Microsoft has a Helm sort of broker as well. Yeah, so that. Yeah. All right. Thank you, everybody.